In this video, we are going to continue our evaluation of graphical solutions. The first question here is, we have been given a linear equation 2x plus 3y minus 8 equals to 0. We're supposed to write another linear equation in two variables such that the geometrical or the graphical representation of the pair so formed in case 1, intersecting lines. We know that for intersecting lines or a unique solution, the ratio of the coefficients must be a1 by a2 not equals to b1 by b2. So for intersecting lines, this is the condition that we are supposed to make. The given equation is, let's first write the given equation, which is 2x plus 3y minus 8 equals to 0. Now we need to write an equation such that a1 by a2 is not equals to b1 by b2. So we can understand that we can frame as many equations as we want, but the question has asked us to frame just one. So let's frame the second equation. If we'll write 4x, that means the coefficient of x for second equation is 4, then a1 by a2 will be 1 by 2, as 2 by 4 will be 1 by 2. Now the only thing that we need to take care of here is the coefficient of y should not be 6y, as if we write 6, then what will happen is 3 by 6 will also give us 1 by 2. So apart from plus 6, we can write any other value here. So let's write plus 7y minus 19 equals to 0. We don't need to worry about the ratio of the constants, as soon as we have a1 by a2 not equals to b1 by b2, the pair of equations will have intersecting lines. Now in the next part, we want an equation which gives us parallel lines. We know the fact that for parallel lines, we should have no solution and the ratio of coefficients should exist like this. a1 by a2 should be equals to b1 by b2, but the two ratios should not be equals to c1 by c2. So the ratio of constants must not be equals to ratio of the variables. So let's frame the second equation in the same way that we framed the first. Let's write 4x only, such that the ratio of coefficients of x should be 1 by 2. Let's write plus 6y this time around, as we want the ratio to be 1 by 2. Now we must make sure that the ratio of constants is not 1 by 2 as well. That is, we should not write minus 16, and in place of that we can write any other number. So let's write minus 25 equals to 0, and we are done, as a1 by a2 equals to b1 by b2, but the ratio of constants is not equals to the ratio of the variables, that is 1 by 2. Now finally, for coincident lines or infinitely many solutions, we know the fact that both the equations must be same. That is, one equation has been multiplied by some constant. So for coincident lines or equations having infinitely many solutions, the ratio of a1 by a2, b1 by b2 and c1 by c2, they all should be equal. So in this case, let's write our second equation as 4x plus 6y. This will give us the ratio of the first two variables x and y as 1 by 2 each, and let's write constant as minus 16, such that the ratio of constants also become 1 by 2. Minus minus gets cancelled, 8 ones are 8 and 8 twos are 16. So this way we have framed the second equation for intersecting lines, parallel lines and coincident lines. You can frame some more equations using the same given equation, so you can do that as your assignment. Now moving on to the next question, we need to draw the graphs of the equations x minus y plus 1 equals to 0 and 3x plus 2y minus 12 equals to 0. We also determine the coordinates of the vertices of the triangle that will be formed by these lines, the lines that we will derive from the given equations, and the x-axis. We need to shade the triangular region and find its area. So let's start by forming graphical equations of the first equation, which is x minus y plus 1 equals to 0. Let's shift y minus y and plus 1 to the other side, and we will get our equation as x equals to y minus 1. Now in order to frame graphical solutions, let's make a box. As we are aware, we need minimum of 2 solutions. Just to be sure, we can make 3 as well. So let's stick with 3. And if you're happy with 2, you can stick to 2 as well. But you need to be sure, absolutely sure about the 2 solutions that you have got if you are sticking with 2. So let's put y equals to, let's start with 5. So we'll get x equals to 5 minus 1. So the value of x will be 4. Next, let's put y equals to 4. So we'll get x equals to 4 minus 1. So we'll get x equals to 3. Let's put y equals to 6. We absolutely have our own choices in terms of putting the values of y. X equals to 6 minus 1 will give us x equals to 5. So we used y as 5, 4 and 6. So y as 5, 4 and 6. When y was 5, we got x as 4. When y was 4, we got x as 3. And when y was 6, we got x as 5. Now let's evaluate the second equation. 3x plus 2y minus 12 equals to 0. So let's first simplify the equation. Let's shift minus 12 to the other side. We'll get plus 12 plus 3x to the other side minus 3x. Y equals to 12 minus 3x by 2. So now let's make a box in order to note down the graphical solutions for this equation. So let's start by putting x equals to 0. Put x equals to 0. Y equals to 12 minus 3 into 0 by 2. So we'll get y equals to 12 minus 3 zeros will be 0 by 2. Y equals to 12 by 2. 2 6 are 12. So we got y equals to 6. For x equals to 0, we got y equals to 6. Next, let's put x equals to 2. So we'll get y equals to 12 minus 3 into 2 by 2. Y equals to 12 minus 3 2 is 6 by 2. So we'll get y equals to 6 by 2. We are making sure we are getting even values such that we don't need to deal with decimals. Y equals to 3. And then finally, let's put x equals to 4. So we'll get y equals to 12 minus 3 into 4 by 2. So y equals to 12 minus 3 4 is 12 by 2. Y equals to 0 by 2. 0 by 2 will give us y equals to 0. So when x was 2, we got y as 3. And when x was 4, we got y as 0. So we have got the graphical solutions for both the equations. Now we will plot it in the Cartesian plane. So we have constructed a Cartesian plane using a graph paper, and we have plotted the solutions of the first equation. 4, 5, 3, 4 and 5, 6. So 4, 5, 3, 4 and 5, 6. Now we will draw a line for this graphical solutions. Here we go. We have the line for the solutions that we had plotted for the first equation, which was x minus y plus 1 equals to 0. Now we will do the same thing for the second equation as well. The solutions of the second equation are 0, 6, 2, 3 and 4, 0. Let's plot them on. So this is the line that we have got from the second equation. The coordinates were 0, 6 on the y-axis, 2, 3 and 4, 0. The equation was 3x plus 2y minus 12 equals to 0. Now the question had asked us to figure out the vertices of the triangle formed by the lines and the x-axis. So this is the x-axis, the horizontal axis, and these lines are intersecting here. So these three are the vertices of the required triangle. So let's plot them as A. This one will be B, and this one is on the x-axis. So minus 1, 0. Minus 1, 0, the second vertex, and the third vertex is 4, 0, which also happens to be on the x-axis. ABC is the required triangle. Now let's shade it. So here we go, we have shaded the triangle formed by the lines and the x-axis. So now let's note down the vertices. Coordinates of the vertices of required triangle ABC. A was 2, 3, B was -1, 0, and C is 4, 0. We are also supposed to find the area of the triangle. Now in order to find the area of the triangle, we will use the formula area of triangle equals to half into base into height. Now the base in case of triangle which is formed by the lines and the x-axis, the x-axis will be the base and the y-axis will act as the height. The case will be reversed if the triangle is formed by the lines and the y-axis. Here the magnitude of x-axis is 4 on the right plus 1 on the left, so altogether 5. From here to here 4 plus 1, 5, and the y-axis is 3. So the magnitude of x-axis is 5 units and the magnitude of y-axis is 3 units. So let's write here base, which we have derived from x-axis, is 5 units, and height, which we have derived from y-axis, is 3 units. So area of triangle ABC equals to half into base 5 into height 3. 5 3 is a 15, 15 1 is a 15, so 15 by 2 square units, or we can say 7.5 square units. So we have got everything. We have made the graphical solution, we located the triangle formed by the lines and the x-axis, we figured out the coordinates and also calculated the area. Now alternatively, if we were to determine the coordinates of the vertices of the triangle formed by the lines and the y-axis, not the x-axis, shade the triangular region and find its area, then our triangular region would have been this region. Y-axis, the vertical axis, and the lines are forming this triangle. So let's name it P 2, 3, Q is 0, 6, and this one will be our third vertex, R 0, 1, which is on the y-axis only. So let's shade the triangle. Coordinates of required triangle PQR are P 2, 3, Q is 0, 6, Q 0, 6, and R is 0, 1. And next we'll find the area of the triangle. This time around, the y-axis will act as the base and the x-axis will act as the height of the triangle. The y-axis has a magnitude of 5 from 1 till 6, so 6 minus 1 will give us 5, and the y-axis is and the x-axis in fact is 2, so the height will be 2. So we have base, y-axis, the magnitude as 5 units, and the magnitude of height in the x-axis for this triangle PQR as 2 units. So area of triangle PQR will be half into base 5 into height 2. 2 will cancel each other, so area of triangle PQR is 5 square units.